and we'd introduce this force. Here, let's just generalize it, a mystery force, and so we wouldn't need normal force. This mystery force would take up the space for normal force, and would then become equivalent to the gravitational force. At this point, because there is no normal force, there is no friction. So, introducing magnetic force.
So how a magnetic force works is that there are two magnets. And have you guys ever played with magnets before and like put them next to each other? So sometimes they'll connect and then sometimes they'll repel each other. So when they're repelling each other, that means the like ends, the positive or negative ends, are both touching each other. So when the like ends are trying to touch, it repels, and that creates the limitation effect.
So that's the general principle behind the maglev train. The magnets allow the train to actually hover around the track. And because it hovers around the track, there's no friction whatsoever. And this train in particular is designed so that the train actually wraps around the track, and because it wraps around the track, it prevents derailments. The track itself has electric current running through it, and this pumps or moves the train on top across the track.
Okay, so now that we've talked about the evolution of trains, do you have any questions?
Yeah, if you're running an electric current, doesn't that defeat the whole purpose of not having electricity in your train?
So you still need electricity and current to actually move the track along. The whole point of having magnetism to the whole thing is that it takes less energy to do this process because there's no friction involved.
Okay, so now we'll talk about the future of trains. And so, does anyone have any guesses as to what this image might be, or what's in this image?
I don't think we launch ISOs.
That's a fair guess.
Is it a train that happens to run on suction? So when sucks air out, when it pushes air in?
Yes, that is exactly what it is.
Okay, so this is known as the hyperloop, and so researchers solve the problems with today's transportation and how it causes pollution and all of the bad things to the environment. So the hyperloop uses renewable energy and is energy efficient and it's people friendly. So that's how this idea was conceptualized.
So exactly kind of like how your classmate described, this train is entrapped in a tube. There's a compressor on the front of the train, and this compressor sucks the air from the front of the train out to the bottom. As the air comes out of the bottom, we can consider this as air bearings. These air bearings are basically what magnetism was or is for the maglev train. It creates this thrust, or this upward force, that prevents the train from resting on the bottom of the tube, thus creating a frictionless environment. One of the beauties about the Hyperloop is that it's speculated to travel up to 750 miles per hour. Does anyone know? Yeah.
Why do we need to go that fast?
Good question. Do you know the distance between New York and San Francisco?
Yeah.
It's 3,000 miles.
I was just making sure.
Does anyone know how long it would take to travel from New York to San Francisco?
Oh, wow.
3,000 miles.
It would take like a lot of weeks.
So it's 43 hours if you to drive straight using the car. It's a 6-hour plane ride, which is honestly not too bad. But in a Hyperloop, this would be a 4-hour train ride. So the Hyperloop is amazing, not only because of its speed, but it could be used for storage or just as a passenger train. Yes.
Can they be any faster?
You're working on it. You're
I'm trying to
working
go
on
like
it.
3,000 miles and blow your face off.
Would you have to like keep on yourself in because it goes so fast?
So that's a huge issue that comes into play when you're dealing with things that are moving at